In. Happy Monday to you. So as a present, I just put up another homework. This is due after Thanksgiving, in case anybody has something else in their life they're trying to avoid by doing extra classwork. Have that. That way you can still feel productive while avoiding the other thing you don't want to do. But while I have this open here, any questions on homework 6, Fun with Piecewise Models? Ejin, hit me. ML for this one. Yep, it says so. Let's see if I can find where it says that. Does it say, it says, did I have it in here? Because you're using ML, did I not say it earlier? But yes, ML is what you're using. That way you can do likelihood ratio tests to do any of the model comparisons, mean side or variance side. Let me, I will fix this text to make sure it says that explicitly, but yes, ML. It says so in the results section, so I did remember to put it there. So there's that. Other questions? Lindsay. Yes. Let's see here. We did, this is the one that we had done in class a while back. So yes, let's see here. Let me do something that will be analogous. All right. Let's say that I have a 2-slope model, and I told you that the third occasion is to be the intercept. So 2 slopes, slope 1 to 3, slope 3 to 6 is this example here. Occasion 3 is the intercept. If I say that, what does that tell you right away to do with occasion 3? Zeros, good. If you set up your pieces right, there should always be one point at which everything is 0. All right. Now, what comes before 0 in terms of numbers? What? There we go. So the occasion before 3 is -1. The occasion before 2 would be -2. Very good. Now, what to put in the other cells depends on which kind of piecewise model you're trying to specify. The easier version and the version that I told you to use for homework 6 is direct slopes, meaning that each variable captures the rate of change during its phase only. So with that in mind, what goes in 4 to 6 here if this first variable is to capture only this much? So 1s is one option. 0s is another. Anyone else want to throw another option out there? Okay, let me get out paint. You can see what the right answer is. So let's say that in this example, we have, let's see, here's -2, -1, 0, and 1. If we had a slope that looked something like this, let's say it's going down. If I coded 0, then it would shut off where it left off at. If I coded 1, it would come up or down. It would change again depending on what the coefficient is. So in this case, these ones are 0 because it shuts off where it left off. Shuts off where it left off being the bigger picture here. Likewise, if slope 3, 6 hasn't started yet, then these ones are going to be 0 also. But after session 3, slope 3, 6 is supposed to index how much time has passed. So what is one more, or excuse me, what is one more between 3 and 4? 1, 2, 3. Now let me make this a little bit more complicated. Excuse me, 8. Let's go out to 9. Now let's say that I wanted to put in, hypothetically, a jump between the happened at slope 3 onward, and then a rate of change that was supposed to pick up for the rest of the time. If I still want my intercept at 3, I know I need a 0 here. Likewise, if this jump characterizes the difference between 3 and 4, what goes in at time 1 and 2? 0. Good. Do I need to do anything different for slope 4, 9? No, it's not awake yet. It's still sleeping. Likewise, if this is to capture the rate of change between 1 and 3, it's still done out here. For 3, 4, though, what do I put here under a 4? 1. Now, here's the tricky part. What goes for the rest of time? Is it 0 or 1? Yeah, see, this is tricky. If I put a 0 here, that means you're going to come back down to where you were. So it would be like this jump is transient. It's like you jump up and then you come back down to where you were. Now that might work for certain types of models, but not in this case, where I want to track the effect of having been through this phase. It stays at 1. So then if you look at just this set of coefficients here, this is a shift in intercept. It directly affects the y-axis between 3 and 4, and it holds constant otherwise. If I'm having slope 4, 9, what goes here? This is a 4, this is a 5, this is a 6. So if I wanted to type this out rather than doing it longhand, I mean longhand would be like if, you know, occasion equals, hang on, let me make this left justified. So if I wanted to do this longhand, it would be something like if occasion equals 1, then do slope 1, 3 equals 1, slope 3, 4 equals 0, slope 4, 9 equals 0, and, right? Longhand would do one of those statements for every possible occasion. Not wrong, but not as parsimonious of code as it could be. Instead, what you could do is say something like this. If occasion is less than or equal to 3, which is our not point here, our intercept, our break point as well as our intercept, then slope 1, 3 equals some function of time, right? Occasion minus, what would create this pattern up here? Minus 3. Else, occasion equals, or slope 3 equals, yes, sorry. Slope 1, 3 equals 0. Likewise, if occasion less than or equal to 3, then you could do this here. Slope 3, 4 equals 0, else slope 3, 4 equals 1. And then last but not least, if occasion is, let's go less than or equal to 3. So I'm doing these piece by piece so you can see the logic for each. Then slope for 9 equals 0, else slope for 9 equals what would create this pattern? Yep, it's occasion minus 3. Question?
Under the slope for 9, why under the fourth occasion is y was not 0?
Oh crap, you're right. Thank you. I forgot about the jump that I just put in. Sorry. Let me switch that one. It's minus 4 on this one. Thank you. Because I have already captured, that's what it would be if it were 3 to 9. But because it's 4 to 9, it starts here. Thank you for catching that. I forgot about this little piece in here. If we were going forward in time, let's say if we put the intercept at the beginning. We had the same slopes, but we wanted our intercept to be at the first occasion. Let's go 0, 0, 0. What goes here? If I want slope 1, 3. 2. Now it needs to shut off. 2. Shut off where it left off. Is it occasion 3 yet? No. Is it occasion 3 yet? Yes. Now it's going to go to 4, right? 1, shut off where it left off. Is it 4 yet? Is it 4 yet? There. Now we're into this piece. 1, 2, 3, 4, 5. So each of these slopes, when you put them in by themselves, would predict change during part of the story, and then it's going to level off afterwards. It's when you put them all in the same model that they each then represent the change during the phase that you want them to. Okay, does that help? Good. And yes, there are questions in the second session designed to help you know if you have figured this part out. Like it says, you know, what is the value of this slope at this occasion? You put down the number you coded. Not in this case. It's balanced data trying to make your life easy. Relatively speaking, considering there's like 100 questions or something, but easy is relative. Other questions? Okie dokie. Well, then you're getting lots of practice with estimate statements and coding in this homework. You shall get even more with the stuff that we're working on now. And also the basis of your next homework, which is a general linear models example with a three-way interaction. That's what you get to play with that. So tell me what you remember from last time. What are we talking about? Interactions. I also would accept the Karate Kid. I promise to teach you karate, even though we're still working on cleaning right now. Yes. Interactions. What does an interaction term do? What's it for? What kinds of research hypotheses would merit the inclusion of an interaction term? Moderation. Are moderation and mediation synonyms? No. Yes. What's the difference? Mediation implies cause. So if you want to say that the extent to which X and Y are related depends on a grouping variable, something like that. The way people would draw that if it were a path diagram would be something like this, where I have a path going from X to Y and a path from group predicting the path. Now that is not a model. That is a representation that does not lend itself directly to a model, but if I wanted to make that into a model, I would put in an arrow from group to Y, and I would add a new box for X times group that explicitly represents the moderation term and have that predict Y as well. That is a model, or closer to it anyway. Mediation would look something like this. If group were a mediator, X causes which group you're in, and which group you're in then causes Y. That probably doesn't make any sense. So, odds are good. If you're thinking of interaction terms, you're thinking of moderation. You can also have various combinations of mediation and moderation, but we're focusing just on moderation for now. Are we talking about the model for the means or the model for the variance? Mean side, these are fixed effects. In theory, yes, you could have random interaction terms. However, I have never seen one converge, ever. So, in theory, possible, but right now we're talking about fixed effects, meaning how we're describing how each person gets a predicted value based on their values of the predictors in the model. Let's see. How do I talk about interaction terms? What do they do? Yes, they impact the main effects, which then impact the outcome. What are the 4 kinds of interactions possible in the world? More positive, less positive, more negative, less negative. Yes, that's it. You just have to figure out which kind you're staring at. How about a 3-way interaction? What does it do? Same 4 things, but to what unit of analysis? The 2-way interactions, and the 2-way interactions then do the same 4 things to the main effects. Main effects don't need those 4 options, they only need 2, up or down. Main effects either increase the outcome or they decrease the outcome. 2-way interactions make those main effects more positive, less positive, more negative, less negative. 3-way interactions make those 2-way interactions more positive, more negative, less negative. Let's see. Estimate statements. Remember estimate statements? Vaguely? Let me pull up an example. Why am I insisting that you learn how to do estimate statements? I want it to do the math for you, indeed, and give you standard errors. And these same concepts apply in any kind of linear model. Beyond regression, beyond multi-level, into SEM, or any way that you can put in predictors, these are skills that are helpful to have. Let me see, where is... There it is. So we started looking at, I fixed this slide, by the way, the corrected version is up. This is slide 9, had typos in it. If you are predicting outcomes, what goes in your estimate statement? Looking for a one-word answer starts with E. Everything! To predict an outcome, every fixed effect that's in your model is relevant, including the fixed intercept. Any fixed effect that you don't include is held to 0. So in this example, if I'm predicting GPA with these values of my predictors, I put in the intercept, and then I put in the values of the predictors for which I want the predicted outcome, multiply them together to put the value for the interaction term. The words refer to the coefficients. So when I say intercept 1, I am asking SAS to figure out what it thinks the fixed intercept is and to add one of those into my predicted outcome. 3 attitude slopes, 12 education slopes, and 36 attitude by education interactions. What do the other 2 lines do? What am I asking for? A slope. Therefore, intercept is not in the estimate statement. I want the slope of a predictor as a function of any predictors it interacts with. So in the second line, I'm asking for the effective attitudes when education is 12. So 12 goes behind the interaction term. In the third line, I'm asking for the slope of education when attitudes is 3. So 3 goes behind attitudes in this interaction term. And then we did, let's see, we did all kinds of stuff. We get the in-class version of it up here. This is my filled-in version. Remember this one? 3-way interactions? We wrote out the functions that would be used to generate simple slopes and simple interaction terms. Search the model, find the term you're interested in, pull out all of the fixed effects that have that term embedded in it, and then you can figure out what the simple effect would be for any combination, including main effects and interaction terms. Fake people is where we ended up with, right? What are fake people for? Making a graph, yeah. It's not a thing. So Lucas asked me after class, how do I talk about using fake people in a manuscript? And what was my answer? You don't have to, no. It's just how did you get the values that go in your plot? And the answer is the model gave them to you. These are model predicted values based on the fixed effects. Fixed effect predicted outcomes. Fake people is simply a way to get them more expediently than writing out the formula for every possible predicted value. So that's where we will start off. Example 2b. So this is the story from chapter 2. The outcome is cognition. These are fake old people. 550 older adults. The data were simulated to reflect a real data set that I have access to, where we have chronological age as a predictor, grip strength, which is a measure of physical function, sex, which is binary in this case with men as the reference group, and 3 kinds of dementia status: people who don't have it, people who will get it some point later in the future and we know about it, and people who already have it. Most of the people have no dementia. I'm going to center my continuous predictors near their midpoints, which is 85 years for age and 9 pounds of grip strength. For now, I am treating the other variables as continuous. The next example, I'll show you what to do to treat them as categorical instead, but this helps drill in the idea of the linear model, I think, more formally. So based on those predictors, the first thing that I have in this example is syntax to create fake people. If you don't have very many cases, you can type it into SAS like this. If you have a lot of cases, I would build an Excel sheet. It's probably a lot faster and less error prone that way. But if you've never seen this before, this is how you enter data into SAS. So data work.fakeAgeGrip, that's the name of my data file. There is no set statement. I'm writing data from scratch. Instead, I have an input statement that lists the name of the variables in the order in which they are to appear. Every single variable that is referenced in your model has to have a value for these cases to get included. That includes ID. So person ID is my level 2 ID variable. In this case, I only have level 2. It's cross-sectional data, people data, and I gave it a value of -99 so that when I sort the data file, they're first, and also because it is unlikely that my real data file would have a negative ID value. Grip strength is the version that's centered, and age is the version that's centered. So I looked up the standard deviations of these variables, and I centered them accordingly to have values of low, medium, and high. So for grip, for instance, I have a strong person here who's 3 units above the mean, an average person who's at the mean, and a weak person who's 3 units below. I did the same thing with 5-year increments for age. And the last 3 variables are for my dementia variables. These are dummy codes, or excuse me, this one's for gender, these 2 are for dementia. This example is really just focusing on age and grip for right now. So I zeroed out everything else so that these predicted values would logically apply to men who do not have dementia. A semicolon goes separately on the next line and then run. And then I merge these fake people into my real data set. So from this point forward, my models are being run on the combined data set of the real people and the fake people. Now, why doesn't this cause problems? Why is this okay that I just made up people and added them to my data set? I imputed. It's a joke. Why can't I just make shit up? Why is this okay? Charlie. I'm creating specific values that I want predictions for, but what is the critical thing that I haven't included with my fake people that makes it okay? The DV. Yes, do not put anything in for the DV. Otherwise, it is not okay. Then you really are just making shit up. So no DVs, only predictors. What's going to happen is that these fake cases will get kicked out of the model estimation. But the command that tells SAS to save predicted values will include them because they were in the data set. So everyone in the data set gets a predicted value, including your fake people. So here's my model. We're starting off with a 2-way interaction in the model. So here's age, grip, main effects of gender and dementia, which we are ignoring for now, and an age by grip interaction term. What's this minus numbers stuff here? What's that for? Centering. Yeah, I'm trying to convey to my reader what a 0 means. So it's helpful to have that in your equation to do so. A couple new pieces of code here on proc mixed. You've seen most of this before. Have you seen this one, name length? That one keeps it from truncating the names of your fixed effects. I think by default it stops printing after 20, and so it squishes your interaction term labels so you can't read them very well. I don't like that. I'm writing out all the terms that I want in my model. I've added 2 new things here on the options after model. One is COV-B. That is the asymptotic covariance matrix of the fixed effects. That's the thing I need to do regions of significance, which I will demonstrate for you. The other, which is something you're going to see repeatedly, outPM. That is a command that tells SAS to create fixed effect predicted values and save them in a data set. The name of the data set in which they are to be saved is right here. I've called it pred age grip. It is going to copy my entire original data set and append columns to the end that have the predicted value and the residual and the confidence intervals around the predicted values. By default, the new column is called pred. I think there's syntax by which you could rename it if you want to. I usually don't bother. Last but not least, ODS output is saving pieces of output as SAS data sets so that I can run my macros to do math on them. COVPARMS is saving the model for the variance parameters. In this case, it's just residual variance. Solution F is saving the fixed effects. And COVB is saving that new COVB table that we need to do regions of significance. Okay, with me so far? All right. So I've included some estimate statements here to try and, I would say, decompose, although that word has a sort of morbid sound to it. Another word that I hear is probe, like you're going to probe an interaction. You heard this before? That makes me very squishy. I think of Cartman and anal probes and things like that. So I don't like any of those words. So we'll just, maybe we're going to describe the interaction by requesting simple effects. That's what we're going to do. So I have picked somewhat arbitrary values at which to request simple age slopes. They're roughly plus or minus 1 standard deviation around the mean. Because these are continuous variables, you could request it for any level of the other variable. So age 85 means all age slopes at a minimum start with the simple effective age. And given that grip is the moderator here, I then talk about what the age slope would be for grip strength of the desired level. So in this case, I've centered grip strength at 9. I want to know what the grip strength age slope would be if grip strength was 6. So I put in a -3 here. This middle one is included for pedagogical reasons. And why do I say that? Why is that middle one unnecessary? I think I heard it, but it was very shy. People who talked, talk again, please. SAS, give it. Yes. More specifically, where does it show up? And not the intercept. It's the right idea, though. Yeah, this is, you note by the 0 here, SAS is going to give this to me as the simple main effective age. It is already at the 0 value of the interacting predictor, which is grip strength of 9 here. I'm asking for the age slope at grip strength 12 here in the last line. Then I'm going to do the same thing, opposite direction. I want grip strength slopes for people of different ages. So now I need one main effective grip strength at a minimum, and then I need to talk about how that effective grip strength differs by age. So I can get for 80 by putting in -5, and for 90 by putting in 5. And the middle line, do I need to write that one? Nope. That's going to be what the simple effective grip is from the model. So that's the one that's provided for me by default. If you don't want to or can't figure out the fake people thing, here is your second option. So it's either or. You don't have to do both of these, but I'm showing them both just so that you have lots of choices. This is what it would take to write out predicted cognition values for all of my fake people. So I'm picking high and low values of grip and age. And because I am interested in predicting an outcome, I throw in the intercept, the value of age, the value of grip, and then the interaction term is their multiplication. Note that these sentences here, these estimate statements, do not include my other predictors. They don't include gender and they don't include dementia group, which means these predicted values are specific to what for them? Males without dementia, 0, 0. I don't need to include variations on gender and dementia group if they're not part of the interaction. They're going to affect where my y-axis is, but they're not going to affect the slopes of the lines and the differences in the slopes. Questions on that? All right, so reading in then, I'll make a note. Yeah, sure. These ones? We do have to include them because some of them are not, the only one that would not be included is this one. Yeah, the one that's highlighted is the fixed intercept for the model when everything is 0. So yeah, whenever you see an estimate where there's only one term that's not 0, it's already in the model fixed effect somewhere. Again, included for pedagogical reasons, so you can see the pattern. So SAS told me it read in 559 observations, but it only used 550. It left out 9. It left out my fake people because they have missing data, as intended. Here's my residual variance. It is now down to 86. Example 2a has the precursor to this where we just had main effects. So if you wanted to figure out R square for your model, you could start with an empty model in which all the variance in cognition is there to be accounted for, and do a pseudo R square relative to this. So what it was minus what it is over what it was. And I have a macro program I put in your homework that you can use to do that, or you can do that in Excel. Solution for fixed effects then. Intercept is 29. That is my expected cognition value for what kind of person? Males with no dementia, who are age 85, and who can squeeze how many pounds of grip strength? 9 pounds per square inch, I think, is the actual measurement. Yep, that's my "you are here" sign. Let's do the main effects here that are unconditional. So I would call these just main effects or marginal main effects, unconditional main effects. The idea is that sex and dementia group do not interact with anything. So the sex fixed effect of minus 3.4 is the gender difference between all people. And it's coded such that men are the 0, women are the 1. So who is lower, men or women? Women, yep. Likewise, DEM NF and DEM NC are my dummy codes that distinguish N, which is no dementia, from future F or current C. So N is the 0, F and C are the 1s in each category. So it looks like dementia is bad for you. Go figure. Newsflash. People who are going to be diagnosed with dementia later on in the study start out 6 points lower. People who already have dementia relative to people who don't start out 16 points lower. And if I wanted to know the difference between the F and C groups, we're going to talk about that next time, but how would I do that? Do you remember? No, don't remember? It's one minus the other, right? So literally that's it. It would be an estimate statement that looks like this. Dem NF minus 1, Dem NC 1. It's the difference between these two coefficients. That's how I get the difference between the F and C groups. Alternatively, Amy, what could I do instead? If I wanted to know the difference between my F and C non-reference groups. You told me you got taught this. That's why I'm picking on you. If you want to know the difference between them and you don't know how to do an estimate statement, what could you do instead? Yes, recenter. You would make somebody else the reference group and then you'd get the missing contrast. So that's the other way of making SAS do the math for you. But we'll talk about that more next time when we do the same type of interaction patterns with grouping variables instead. So we got the intercept. Simple main effect of age is right here. So why am I saying simple? Or conditional? That's another one. It's the effective age when grip strength is 9 because it's part of an interaction term. So yeah, you can't just say the main effective age because it's different for different people as a function of grip strength. So these are years of age as a unit. So for every year older you are, cognition goes up or down. For every year older you are, cognition goes down. Yeah, not a trick, just looking for the minus sign here. Yes, by 1/3 of a point. So 1/3 of a point per year if you are someone of average grip strength. Let's see what the interaction term does to that. So the simple effective age is minus 0.3 if grip is 9. For every pound stronger you are, the effect of age becomes, which of the four is it? Less negative, yes. For every pound of grip strength, the age slope becomes less negative by 0.12. The age slope becomes less negative as grip strength increases. Can someone give me a more GRE sounding word for less negative? The age slope diminishes. The age slope is mitigated. Can I say that one? Come on, you guys are smarter than me. Is the age slope getting stronger or weaker as grip strength increases? Weaker, less negative. If there's a less in front of it, it's weaker. So if you're strong, does age matter more or less than if you're weak? Less. Age matters less if you're strong. Age matters more if you're weak. Let's go the other way. My simple main effective grip. For every pound stronger, my cognition is higher or lower? Higher by 0.6. For what kind of person? 85-year-old. Yes, simple main effect. So now age is the moderator. Let's pick up the interaction term on that one. The simple main effective grip is 0.6 for 85. For every year older, the simple main effect of grip becomes, which kind is this? This is a more positive, yes. If you're 86, your grip strength effect is 0.12 more than if you're 85. So grip strength matters more in older people. Old age enhances the effect of strength. That's about the best I can do. Old age makes strength more salient. I don't know, going off the rails a little bit, but you know what I'm saying, right? More positive is maybe not something that everybody would resonate to, but you can find other words to convey the same thing. Okay. With me so far? All right, so let's look at our simple effects here, because these are a way to convey more specifically those same patterns of matters more or matters less. So my h-slope, as estimated by the model by default, is the minus 33 there, minus 0.33 for people of average strength. The h-slope is stronger in weaker people, and it is weaker in stronger people. So at what point would I say age ain't nothing but a number? Is that Aaliyah, by the way? Anyone? No? Age ain't nothing but a number? Someone asked the Google for me. I think it is, but I could be wrong. At what point of grip strength is age ain't nothing but a number? Make a guess. Does age matter if you're 9 pounds strong? She's like, what number am I looking at, please? I can read minds. It's amazing. Let's look at these three numbers right here. Just these ones, okay? So, does age matter if I have 9 pounds of grip strength? Yes, this is my age slope. For that kind of person, it is significantly negative. Does age matter if I have 12 pounds of grip strength? No. So at what point is age nothing but a number? Somewhere in the middle, right? Somewhere between 9 and 12, age don't matter no more. Likewise, does it matter if I'm strong if I'm 85? Yes. Does it matter if I'm strong if I'm 80? No. So at what point do I have permission to not go to the gym anymore and sit and eat Twinkies? 83, maybe? Somewhere in the middle, right? I love making causal statements out of correlational data. It's fun, right? Yes. So yeah, at some point, so I could keep stabbing at this. I could write estimate statement after estimate statement, trying to narrow in like exactly at what point these things become non-significant. Or I could do what? Remember the thing with the cove B? The cove B is the asymptotic covariance matrix. What is it used to help calculate? Regions of significance. Yeah, we're going to do that. Here are my predicted values by which, and here are the same predicted values that came out of my fake people. And here's the picture I made in Excel. Everyone's like, oh, R makes great graphics. You know what? Excel does too, damn it. Meh. So we can talk about this interaction as the difference in slopes or the difference in intercepts as a function of these lines. So if I go one way, I can talk about the effect of age as the slope. And here, if you're strong, grip equals 12, age don't matter. It does matter if your grip is 9, and it really matters more if your grip is 6. Likewise, if I go with the effect of grip, does grip matter if you're 80? No. Here's my significance test for that, by the way. But if I go with visual analysis, which is actually a thing, and I'm going to go with no on this, right? How about this one? And this one? Yeah. So here's my cove B. I have bolded the values in here that you need to plug into either the macro or my Excel sheet, your choice. What this thing is the covariance matrix of the fixed effects. When it's going through the estimation process, it first finds the variance components, and then given those variance components, what the fixed effects should be fall out. The standard errors of those fixed effects also fall out as well. On the diagonal of this matrix is the standard error squared, so the variance of the fixed intercept, the variance around the fixed effective age, and so forth. To do a regions of significance calculation, what you need are the standard error squared for the main effective age, the standard error squared for the main effective grip, and the standard error squared for the interaction term, as well as one of the covariances. Did I highlight that one? Yeah. Well, in this one, my macro does it for you. You have to find it in Excel. It's a covariance between the interaction and the main effects, I believe. So I wrote a little macro to do this. You tell it where the fixed effects are. You tell it where the cove B data set is. You let it know which interacting variable you want to be predictor and which is the moderator. You tell it where the moderator is centered, what the name of the interaction term is, and order equals 6 is where in the fixed effects the interaction term is. I'm not a good enough programmer to avoid some of those things. It's just easier if you tell it where to look for things. Number 6 is in which fixed effect is the interaction term? So, yeah, 1, 2, 3, 4, 5, yeah. So it's that. The 6th predictor is the interaction term. So given that cove B table and the main effects that we saw earlier, it computed regions of significance for the effective grip as a function of age. So I'm giving you the centered values and the uncentered values. The uncentered are a little bit easier to translate. So we have a cutoff of 70 and we have a cutoff of 82. So these are the values of age at which you can expect the effective grip to be positive, negative, or 0. So let me go back to the graph here. So 82, that's where grip strength matters. Before then, it's Twinkies and Netflix. After that, get to the gym. So after 82, the effective grip is significantly positive. Between 82 and it said 70, it's non-significant. And because these are parallel lines, it's going to flip direction and become significantly negative before 70. So this is the point at which I would look at how many people are in my data set who correspond to these ages so that I can know what proportion of my sample is expected to have a positive grip strength effect versus a negative or a non-significant grip strength effect. Likewise, if I go the other way, I can talk about the predictor being age and the moderator being grip strength. And I come up with grip strength of 9 and 18 as my cutoffs for when age matters. So age has a, was it 9? Oh, I lost it. Hang on. 9 and 18. Okay. So age has a significantly negative slope at grip strength of 9 or lower. Between 9 and 18, its slope is non-significant, and after 18, it would be positive. So then, how many people in my sample have these levels of grip strength? Then I can talk about what proportion are expected to have a negative age slope versus a non-significant slope. Here's my model R square to calculate the R square for this model and the change in R square. So in example 2A, I had fit an empty model to get the total amount of variance in cognition to be predicted. I had then done a main effects only model, which is this COVE-DEM is what I had called it. That had captured 27% of the variance. My model with this interaction captured another 1% of the variance, creating a total of 28%. All right, questions on that? All right, then let's step it up a notch. Let's add a bunch more stuff. Why not, right? Up to a 3-way of age by grip and sex. I'm also adding all of the lower order interactions that are necessary for that 3-way interaction and sex by dementia group, because that will be in our example to look at next time. Accordingly, I am expanding my collection of fake people to include the same 9 I had before, but a set of men and a set of women. Here's my model. So I'm interested in describing this 3-way interaction, age by grip by gender. So we'll pull apart each of the main effects and then each of the relevant 2-ways. So there we go. First step, if I want to describe what the age effect is for different kind of people, I pull out all of the relevant terms from my model in which age is included. So that includes the main effect of age, which is beta 1. It does not include the other main effects. And it does include any interaction terms that include age. So I've got age by grip, age by sex, age by grip by sex. And so I have pulled the age variable out of this term to create one composite equation here. So the age slope is given by all of that. At a minimum, the age slope is given by beta 1. But these interaction terms say that it's only going to be equal to beta 1 if I have grip of 9 for men. Otherwise, it's going to be some other number. So this equation right here, beta 1 plus beta 6 times grip plus beta 9 times sex plus beta 11 times their interaction, that is instantiated in the estimate statements below. So age 85-1 says start with at least 1 beta 1. Then fill in the values for the other terms that pertain to the level of grip and gender that I want. So if I want grip strength of 6, I fill in a -3 everywhere that I see grip 9 in this line. Likewise, if I want men, I fill in a 0 everywhere that I see men. So I've got a -3 here, I've got a 0 here, and what is -3 times 0? 0. Do you notice something special about this second line right here? I don't need it. Why don't I need it? It's given by the model. This is what the simple main effect of age will be up above in my solution for fixed effects. And I know that because all of the other covariates that would adjust the main effect of age are zeroed out. So this one would be beta 1 plus nothing. Let's go down to this one right here. Women who are on the weak side. Grip of 6. If I want a grip of 6, I fill in -3 for grip. I fill in 1 if I want a woman, and -3 times 1 is, hey, -3, yes. Not a trick. Not a trick, I swear. And then a strong woman would be a 3 and a 1, creating a 3. So you just have to be internally consistent in how you label each of these variables here. If you give it a -3 in one place, it carries over to all of the other places. So everywhere you see grip, you put the same number. Everywhere you see gender, you put the same number. Let's do it again. What am I asking for now? Feel free to read from the screen. Simple main effects of grip. And if I didn't have such helpful labels, how would you know that by staring at those estimate statements? They all have grip in them, and grip 1. Whatever you want to know goes first with a 1 behind it. From there, it's whatever modifies it in the equation. And yes, the common term in all of these things is grip. So I start with beta 2 at a minimum. I then fill in how grip varies by age, the effective grip varies by age, the effective grip varies by gender, and then I multiply the two together to give me the value for the three-way interaction term. Last but not least, the simple main effect of sex at different levels of grip, at different levels of grip and age. Same pattern. I know that I'm asking for a gender difference because each of these terms has gender in it, and I have gender 1 as the first term. Are you with me? See, once you see the pattern, you can't unsee it. It just takes forever to see it sometimes. Just like the stupid magic eye posters that I still cannot see. Two-way interactions. Within a three-way interaction, there are 3 different two-ways. The 3 ways interaction's job is to take the 2 ways and make them more positive, less positive, more negative, or less negative. So here are the set of estimate statements that you would write to figure out what happens to the 2 ways. And yes, you will get to practice this in homework 7. So first one, age by grip. I pull out all of the terms from the model that have both of those put together. So no terms that only have one or the other. The unit that I'm trying to ask for slopes for is the interaction. So I would indeed call this a simple interaction, or a conditional interaction if you prefer. So I'm asking here, what is the interaction for men and what is it for women? If I want to know what it is for men, I fill in a 0 for gender. If I want to know what it is for women, I fill in a 1. So there's 3 pieces of information that I might know with respect to this two-way interaction. Is there an effective age by group for men? The model gives that to me directly. The first statement is unnecessary because this is what is given by the model by default. It's for the reference group of men equals 0. What the effective age by grip is for women is not given by default. I have to ask for that. That's a linear combination of the beta weights. The third piece of information then is what is the difference between men and women in their age by grip interactions. Do I have to ask for that? Jihan says no. Why do you say no? Because you're right. Beta 11, yes, that's what this means. If you look at the difference between these two lines, it tells you the answer. The first line gives me the interaction for men. The second line gives me what it is for women. How do these two lines differ? Only in the interaction term. The interaction term is the difference in the interactions between men and women. The three-way interaction of age by grip by gender is the difference in the age by grip interaction between men and women. Likewise, if I do gender by age, that's conditional on grip strength. So I could ask if there's an age by gender interaction for people of different strength levels. So I'm filling in grip strength as my moderator out here. And last but not least, I can ask for sex by grip as a function of how old you are. So there's what I want, and here's how it differs by people of different ages. And yes, you can do regions of significance on three-way interactions as well, although I don't have an explicit example of that. So here are my fixed effects provided by default out of the model. Let's look at this simple main effect of age. Who is this for now, given the rest of my list? Is it conditional on grip? Is my simple main effect conditional on grip? Yes, because it interacts. How about gender? Yes, because it interacts. How about dementia? Not yet. No. Likewise, grip 9, conditional on gender? Yep. Conditional on age? Yep. Conditional on dementia? Not yet. Intercept, conditional on everything. Age by grip, conditional or unconditional? Conditional on, yeah, this is specifically for men. So if we look at this right here, the age by grip interaction is specific for men. Let's go this way. So here's my effective age. For men who have average grip strength, it's significantly negative. The effective age becomes significantly less negative if you're stronger, 0.2 less negative for every unit grip. And that tendency for age to matter less in stronger people is reduced in women. There's your three-way interaction. I'll say that all again. You have to get creative sometimes in how you talk about these things, but start here. Age is bad for you if you're a man of average strength. Age is less bad for you if you're a stronger man. But the extent to which age is less bad for you if you're stronger is reduced in women. I'll try again. Age is bad for you if you're average strength. Age is less bad for you if you're a stronger man, but the extent to which age is less bad for you if you're stronger is diminished in women. Drop the mic. And this is the point at which reviewer 3 says, what? Like, oh my God, I can't even. And you're like, fine, here's your picture. See, age is bad for you. Slopey line, age is less bad for you if you're stronger, less slopey. The extent to which that occurs is diminished in women. Lines more closer together and slopey. I could have made these plots a whole bunch of different ways, but when you have a situation in which one of your variables is a grouping variable that lends itself nicely to separate pictures, it's easier to show lines as slopes for continuous variables for different types of people. But I could have done like age by, or I could have done gender by grip for old and young people or something like that. So I could have done whatever I feel like here. But fortunately, I'm ignoring one thing here. Three-way interaction is not significant. So if I wanted to interpret any of the coefficients from this model, I still have to keep them conditional. They are still conditional on the interactions that are part of the model, regardless of whether or not they're significant. The fact that it's non-significant could provide me with justification for reducing the model down to get rid of the three-way interaction in whichever two ways are non-significant. Yeah, so this is a common thing that folks, I think, misinterpret. If I want to talk about any of these numbers, I have to talk about them using the conditional language that I just gave you. 4 men, 485, 4 grip strength 9, even though the interaction is not significant because it's still in the model. The numbers themselves are still conditional. I would have to get entirely new numbers from a new model that doesn't include the three-way to know what they become. Want to do, let's see, one more? Let's do that. Let's do these three. Start with grip instead. Being a strong chick is good for you. Being a strong chick who's old is even more good for you. Meaning the effective strength matters more in older women. Or no, hang on. Yes, the effective strength matters more in older men, excuse me. Whew. The extent to which it matters more in women is less. Yeah, should have went with that third Mountain Dew. I'm sorry, I'm running out of steam here. But you get it though, it's algorithmic. What it is plus what modifies it. So you can ask for these predicted slopes for any combination of things that would help you figure out what the heck your story is. So here's all of my simple main effects of age, simple main effects of grip, simple main effects of sex, and here are my two-way interactions for different kinds of people. So yes, here's age by grip. Age by grip matters for men, it does not matter for women. The difference between these two coefficients, though, was only marginally significant, p equals 0.09. So here's my fake people, there's my pictures, and there's the end. Ta-da. Wasn't that fun? In like a sick, twisted kind of way, wasn't that just a little bit of fun? Well, we're going to have even more fun next time because we're going to do grouping variables. And how do you do all this stuff if you have lots of groups? That's next time. So, office hours start now. Please let me know if you have homework questions or otherwise.